Hey, how you going there? Hey, Anthony here, Total Lifting Solutions. I've just dug up some drawings for this job down at Lidcombe, and I thought I'd go through a little bit of an explainer so you can share this message at the same time. So basically, if somebody rings me up and says, "Oh, the lift's not working," I'll steer him towards the red VSD. Now, the red VSD is going to have a what's displaying on the VSD. It's either going to be U or it's going to be F8 or stop. Now, if stop's flashing, you need to push the green run button. There's a lot of extra stuff I can go into later on. But basically, if stop's flashing, it's got to push the run mode. Now, if stop's solid, everything should be good to go and it should run. There's only one reason that it wouldn't run in that state. Having said that, if it's F8, then that would normally be what I'll call a mechanical obstruction. It could have gone into an overbalance. I've seen on this particular lift where they were mucking around and it would reference. So let me go into the reference cycle for the moment. If power's lost, it will automatically go into reference mode. It will come down from wherever it is. It doesn't know where it is until it references itself, and it comes slowly down to ground level basically. It sees its signal at ground level and then comes back off that, and basically that becomes first ground level again. So having said that, F8 would be mechanical. When it's reset, it would go through a reference run. Now if it's U, then that's safety circuit. So safety circuit's door open or what have you. And I noticed on one of the images that there was a bent switch. When I say bent switch, it was like there was a bolt coming through the roller door, and it had potentially on the outside the second part of the magnet might have misaligned or something like that. Now, so that to me, and I know that there's always further questions from these type of messages. So then we start to look at, all right, well, let's go back to the reference run for the moment, and the sensors more specifically. Now talking around those. So the bottom has two sensors, and the top has two sensors, and the bottom has what we call the door zone as one, and reference or lower limit as the other. Now, normally I would position door zone slightly higher than reference, yeah? So you'd find that the reference is the lowest one. Now those ones are normally closed, okay? And on the top it's a reverse of what I've just said. So the door zone would be slightly lower than the over travel, which is slightly higher. And again, the lower limit and the upper limit, they're normally closed wires. Now that can become a thing later on, I'll call it. If it doesn't run and it says stop and all these sort of things, I'd normally start steering towards have we got 24 volt going to terminal 1 and terminal 3 in the red VSD, yeah, and that basically starts to filter out that. Now going back to the switches themselves, they're a magnetic proxy induction magnetic proxy switch. They'll travel around about, I'm told 60 millimeters, so they're quite a big coverage. You've got your lead in, lead out type angles and things like that, which can be a bit of a thing when we talk about the lower reference position. But looking at the images, so we've got to have the magnets, and on that lift, because it's got doors at the front and doors at the rear, or we always, for the record, we always call the bottom the front. So on that lift, where I'm looking at it, the panel is actually on the front left side, yeah, on the left hand side. Now as we go up, I don't know what it is. It's almost as if there's a bin chute or something going on with the bins at level 3, because the last time they screwed it up, pretty much the same scenario, they'd cleaned up door 3. Now they might have been going to 4, but it's like it's going up, and it's pushed in at 2, It basically almost looks like it slides up against the wall, and then catches when it goes past the. It's almost as if it's going to level 4 when this stuff happens. And last time they broke one of those switches. Now, let's say that we've got it all running and everything was working properly for the moment, and we can come back out of that. So I'm trying to. The cycle is that when the program basically says when we go into a floor number, we're going to arrive at the particular floor number and the door will automatically open. It will only be automatically open when it knows that it's in a safe zone, door zone. If one of those switches is broken or the magnet's gone, then it won't actually operate in the door zone. It won't know it's there, and it won't trigger to open. Going back to the floor levels, yeah, the floor levels are actually set in the VSD, so they're a hard entered number, and so we've got, you're going to stop pretty much on pretty close to the millimeter. It's not elevator, multi-story elevator city type technology, but it's got maybe a little bit too techy, but there's an encoder inside the motor. It's doing a motor count. Based on the amount of counts is the number that gets set in for the floor levels. When it's referenced, that's its 0, and now it's always going to move towards those measurements. So again, that means that it could stop at level 3, but the door's not opening. And now the door's not opening because the magnet's not there, or the switch is stuffed. And those switches are normally open circuits. And I think if I was now looking at it, let's say we've kind of understood the operation. I've got drawings here I'm going to share as well. But let's say that it was now, what's the word I'm looking for? Let's say it was all operational. We're going out to do a routine service, and I'm going to suggest that on this particular lift, the roof is not designed for standing on. It is not designed for standing on. It was designed to be able to lift out. However, having said that, I've sort of stepped around the perimeters and not in the middle. We could sort of beef up the center so it could become a bit more of a workstation. But the panels were created so that you could actually pop them out from the inside, like a lift-up ceiling type setup. The most critical thing that I would look at on our lifts from a routine service point of view is the chain sprockets have got a taper lock in them onto the drive shaft, and until they're, let's say it's 3 months down the track and it's been running, they can work loosen a little bit until they're tensioned right, until they've worked themselves in and tensioned up. That's probably the biggest thing that I look at in the core service aspect. Grease the drive shaft, check the grub screws in the sprockets, and they're a bit of a prick of a thing to do. And yeah, look, there's other stuff that I won't get involved in on this particular video, but that I think pretty much summarizes this one. I will add one more piece, sorry. On all the doors, because they're on the other sides, there's actually multiple magnets on that job. So, if I'm looking at front back type thing, they're sitting on top of the platform itself. So the magnet is traveling up and down. And if we need more magnets or something to that effect, I've got magnets from JCar and sorted it out like that as well. So pretty easy to do. Yeah, hopefully this helps, and I'll send through some drawings as well. Cheers. Bye for now.